Welcome to this tutorial on joining sketches together. Now, as someone who spends quite a bit of time on Facebook groups and various forums, one of the things I constantly see is people struggling when they've taken two or three examples of code. They're trying to put them together and they just cannot get them to work. They're tearing their hair out and they cannot work out why is this not working. So what I'm going to do today is we're going to go through some of the common problems that you will find when joining sketches together. Now, before we even start, the Arduino is designed to help people learn. And unfortunately, if you don't want to learn, then you're not going to get anywhere. So this tutorial may take a little bit of time, but it will save you a lot of time in the long run. But if you're in a hurry, press the skip button now and find something else, and you'll be back later when you're stuck. So let's get started. Now, what we're going to do today, we're going to join two very simple sketches together. I'll just move over to my main screen so you can see the first sketch. So we're going to start with the most basics of sketches, and if we go to our examples, basics, blink, and just about everybody who's bought an Arduino has used the blink sketch. Let's have a quick look through the code. Pin mode starts the built-in LED, sets it as an output, sets the pin high, waits 1 second, sets the pin low, waits 1 second. Everybody's seen this sketch, and it's a very good sketch to test that your Arduino is working. Now, what we're going to do is build something based on this sketch, and then what we're going to do is join something to it that allows us to use buttons to control our sketch. And what we're going to look at is how the different issues arise. When my son started to program the Arduino, he gave up actually after about 2 days. He just loaded this sketch and he just thought he was away and he would just copy examples. One of the things he didn't learn was how to program. Now, we're going to go through some of the issues today, but at some point you're going to have to learn the basics of programming. Now, on the Digital Town site, there is 11 lessons for the basics of programming. You don't need to learn them all off by heart, but they'll just give you an overview of the different issues that you'll face, and they start at a very basic level. So let's start. Even with the blink sketch, there can be problems, and so let's go through it. So what I've done, I have rewritten the sketch. Now, the first thing is the blink sketch uses LED built in. Now, weirdly, I'm not going to use that. The LED pin is pin 13. Now, you might wonder why I'm not going to use LED built in. It's because on certain boards, the LED that's built in isn't on pin 13. So if you're using something like an ESP32 or some other board, if you get used to using this particular function, then it's not going to work. So why bother learning bad habits from the beginning? Now, the other thing you'll see here, I always put a sort of comment block in the top of my code. Tells me what I'm doing with the sketch. I put the sketch name in. I put the date in that I wrote the sketch. And here, the other bit that I put in the top is the pins that I'm using. So on this one, we're going to be using pin 13. Now, you might think that why even bother? Now, I'm just going to bring another bit of code over. This is a far more complicated sketch, but if you look here, you'll see that I've got a whole list of pins that are being used. I've got other sketches where I'm using over 40 pins. If you're using an Arduino Mega or a Dew, you've got a lot more pins to choose from. And it's important when you start to try and join sketches that you keep a list of the pins that you're using. If you don't, you're going to get to the point where you're trying to do two things with the same pin. So by keeping a list, it ensures that you don't have pin conflicts and if you do start to have a conflict, you can start to work out how to fix it. So let's imagine that we have a button that's on pin 13. Then what we might have to do is either change the button to pin 12, or if it's got to be on pin 13, we'll have to put an external LED on a different pin. So keeping a list of the pins that you're using is important when you're joining two sketches together. Now, the original Blink sketch doesn't use the serial monitor, but if you'll notice, I've started the serial and I serial print the sketch name right at the beginning, and you'll see here that it's already come up. Now, the reason I do this is that it helps me to see that the latest version of the sketch has actually uploaded. Sometimes you can think that you've uploaded a sketch and you haven't. So by making the name come up, I know that it's happened. Now, another thing, when you're looking through sketches, what tends to happen is people come down here to the loop and they're looking at what's going on in the main program, and they forget little things in the setup, like the pin mode. So we've set LED pin as an output, so LED pin is our pin 13. I've set that as an output, ready to go. I remember watching my son trying to get an LED to work, and because he wasn't declaring the pin mode, he'd got everything down here but no pin mode, nothing was working. Again, sometimes less haste, more speed. So I've rewritten the sketch, the standard Blink sketch. This time I've used LED pin instead of built-in, how do they say it? LED built-in. So that is how the sketch would be. Now, if we try and control this with a set of buttons, we will have some issues. But what I've done is I've extended the sketch to show us, to, if you like, exaggerate the issue. Now, let's have a quick look through the sketch and explain what's going on. So we are setting a pin high, so the LED comes on. Then we're using delay. Now, one of the issues with delay is it basically tells your Arduino to do nothing for the length of the delay. So during that time, if I was to press a button, nothing's going to happen, because if you think of delay as basically putting your Arduino on pause, nothing is going to happen while the system is on pause. And so if you can imagine, to set the LED pin high is microseconds. So actually, during this program, the actual program is running for microseconds, and if you like, for the rest of the time, basically 2 seconds, 2 1-second blocks, the Arduino is on pause. Now what I'm going to do is I'm going to comment that out, and then what I've done to make this a little bit more interesting, and again, this is something important when you're trying to join two sketches together, make sure you understand how the two sketches work. So what I've done is, instead of just putting the LED high and then low, I've played with the sketch and I've created an SOS sketch. So for those who don't know your Morse code, it's ... .. So what I've done is we're going to put the LED high for 0.2 of a second. Then it's so we go high, wait 0.2 of a second, low, wait 0.2 of a second, high, low, high, low. So we do that 3 times. Then we've got 3 dashes. This time we're going to go high. We're going to wait 0.6 of a second, then a 0.2 second gap, 0.6 of a second high, and so on to get my 3 sets of dashes. You notice I wait 600 at the end. That's to give a break between the letters. Again, we've got it here. Then I do my last 3 dots, and the last dot I wait for 2 seconds once the pin has gone low, and it will repeat the whole thing. Now, if you upload that to your Arduino, you will see a lovely set of ... from your green LED. Now at this point, you haven't really got any circuit attached to your Arduino, but what you now need to do is build this circuit, because we're going to attach a button. It's very simple. You have a push button switch. One side goes to the 5 volts, The other side goes to pin 8, and then there is a 10k resistor that goes through the black wire to ground. For those of you who don't know, you need the resistor there, because if you don't, when the button isn't being pressed, it won't truly go to ground. Again, bit of an electronicsy thing, nothing to really worry about at this point, but trust me, you need the circuit as it is explained here. So what we're going to do now is we're going to join two sketches, and the second sketch we're going to pick, if you go to the examples, go down basics, digital, and the sketch we're going to use is button. Now button is a very simple sketch. If we look again, we're using an LED, pin 13, written correctly. So we've got an LED pin as an output, we've got a button pin, which on their example is pin 2, on mine I'm using pin 8. Again, I'd always encourage you, experiment, change the pins around, start to get a bit of a feel for how something's working. They've got an integer called button state, and then what happens is in the loop we constantly read the button pin to see what state it is, and if button state is high, which is equal to 1, it turns the LED on, and if we let go of the button, it turns the LED off. Now I would advise you just to upload this button sketch to make sure that your sketch is working, because what we're going to do next is we're going to link this basic button sketch to our SOS sketch. Now this is a bit of an unusual example for me because it doesn't work. We're going to see why. So what we're going to do is we're actually going to make the mistake that many sort of beginners will make. So here we have my pins listed again. Pin 13 to a built-in LED, pin 8 is the button pin as we saw on the diagram. I've got them here. There's a couple of constant integers. Again, if you don't understand things like this, in the tutorial I did on the Digital Town website, the 11 lessons, it goes through all of these basics. We've then got the serial beginning. We've put out the sketch name. Now if you look over to my COM window, you'll see it's endlessly going up as button released, and you'll see why in a minute. I've got the pin mode. The LED pin is an output. Pin mode for the button pin is an input. We've got our integer button state. I've put it as a local variable rather than a global variable. And then what we're doing is I've taken the button sketch as we saw it before, but instead of it putting the LED on or off, if the button is pressed, then what it does is it prints out button pressed over onto the right, and then it works through our SOS. And then what I want to do is if I release the button, I want it to stop. So I'm going to turn the LED off. Now we've got the COM port running because it actually helps to show some of the issues. One of the reasons I did the SOS sketch is it takes about 6 seconds to go through its little sequence. So keep your eye now on the COM port, and I'm going to press the button and you'll start to see the issue. So the button is pressed now, he says. Hang on, the button popped out. Button pressed. I've now released the button, and guess what? It still says button pressed. And that's because right now, there it is. See, it's now released. I'm going to press the button again. I've released the button, but it still says pressed. And the reason is that at this moment, my Arduino is working through this sequence of flashes. And the problem is that between each flash, we get a delay. And at that point, the Arduino can do nothing. The pause button is on. So it doesn't matter the fact that I've released the LED, it's still going to run through this sequence. So what we have to do is actually rewrite our code so that it can monitor the buttons and work its way through the LED sequence and know when I want to stop because I've released the button. And this is where most problems come in when people try to join two sketches together when they're a beginner. They don't realize that things like the delay is blocking anything else from happening. It's probably the biggest error that I see among beginners. So what I'm going to do now, we're going to look at a third sketch. Now with all these sketches, they're going to be on the Digital Town website. You can download them later, play with them to your heart's content so that you can start to understand the problem. But now what I'm going to do is put a third sketch up and show you how we start to fix the problems. Okay, so here we are on sketch version 3. Now one of the things I want to do in this version of the sketch, if you notice I've still got the old sketch running on the serial monitor and it's constantly writing button released. I only want it to write button released once and button pressed once. So again, part of my goals of this sketch is to get rid of that mess. So I'm going to just upload the sketch now. And while that's uploading, let's go through the sketch again. So again, pin 13, pin 8, I've listed my buttons. Then what we've got an issue with, and what I'm going to do is go down to the bottom first. And what I've done is I've broken the sketch into two sections. The first section is going to deal with the buttons. The second section is going to deal with the LEDs. So tab that down a bit just to get it out of the way. So the buttons, right. We've got our button state as we had before. So button state checks, it does a digital read on the button pin. Again, if you don't know how digital read works, there's a quick tutorial on the Digital Town website just on reading on what digital read means. Or don't forget, in the reference, never ignore the reference, because if you go in the reference, guess what? There's a whole example on digital read. So the button state. Now we want to know if the button is changing its state. So what I've done, and this is something that you have to learn when you start to join these sketches together, all of a sudden things get a little bit more complicated. So I've got an integer called the last button state. So what the sketch now does is it says if the button state is not equal to the last button state, then I've done something. I've either pressed the button or I've released the button. So next what it does is it updates the last button state to the button state as it is now. But then it says, okay, if something has happened, is the button state greater than 0, and which is a 1, which is high. Now, if it is, then what I've said is print that the button has been pressed. Then what we've got, if it hasn't, if I've released the button, serial print the button has been released. And you'll notice what I do is I tell it to turn off the LED, set the its value to low, and you'll see I've got this other thing in here, LED sequence position. You'll see it there again when it's pressed, and the LED timer, and that's to do with how we're now going to control the LEDs. So as you can see, before the button code was very, very simple, but when you start to join two sketches together, if you want those buttons to be available at any time, these are the sort of modifications that you're going to have to make. Now what we're now going to look at is what I've done with the LED sequence. So all of a sudden the code has shrunk. You remember before I'd got a massive list of everything that went on. I'll just bring it back in so you can see it. there was all those delays and, you know, setting the pin high, setting the pin low. Where has it all gone? So what's going on here? So it says what we're using here is what I call a millis timer. So the first thing is I've got an LED sequence position and an LED timer. Now if we go up my code, the LED timer is an unsigned long, and that is giving me a time when I next want the Arduino to check if something has happened. So when the button is first pressed, if we go to if we look at this bit of code here, it says if I've pressed the button, set the LED timer to 0. Now as soon as I set it to 0, millis is the number of milliseconds since the Arduino was turned on. So if I've set the LED timer to 0, millis is always going to be greater than the LED timer. And we've got here the LED sequence position is smaller than 18. We'll have a look at the sequence position in a minute, what it means. But it's saying if those two conditions are met, then it wants to go through the next part of the code. So let's have a look and see what on earth is going on here. So before in my code I had all of these set a pin low, wait 0.6 of a second, 600 milliseconds. I'm just going to put that code over here, make this window a little bit smaller. And what I've done here is I've put all of this information into an array. Now I'm going to be honest with you, when I first started programming, arrays was something that I could not get my head around at the beginning. Now I've done a tutorial on variables and then a second one on arrays on the Digital Town website that link together to give you a very basic overview of how arrays work, to try and give you a mental picture to work with, because they are a little bit complicated when you first look at them. But if you can imagine, an array is a bit like a car park where you can store multiple vehicles rather than one vehicle. So in my array, it's a two-dimensional array. So we've got 18 sets of values, and each of those 18 lines has two different values. The first value, 200, is going to be the delay, as we see on the right here. So if we work through this, the first part, it sets the value to high and it waits for 0.2 of a second. That's what we're seeing in that bit of code here. Then in the next little bit of code, I'm going to set the value low. I'm going to do it for 0.2. I'm going to go high for 0.2, low for 0.2, and as we work down, all of a sudden we get to this bit of code where it goes low for 0.6 of a second, 600 milliseconds. Then we're doing the dashes, and hopefully you're getting the picture now. So 600 milliseconds high, 200 milliseconds low, 600 milliseconds high through the code. Then we do the dots. So now all of this information is stored in an array, and then I've got an LED sequence position that helps me to keep track of where I am in the array. Now you remember I said there are 18 elements in the array. That means that the first element starts at 0 and the last element is at 17, because there are 18 parts to the array, but 0 counts as a position. You'll notice I set the default position to 100. So that is nowhere in the system. Right, let's get down to what's going on. So if I press the button and the system starts, it says, okay, let's press the button. We're going to set the sequence position now to 0. We're going to set the timer to 0. So our conditional statement says, well, okay, we know millis is greater than the timer, and the LED sequence position is smaller than 18. So then what it does is it digital writes the LED pin to the, hang on, let's just expand my window. It's setting the pin to the LED sequence position. So our LED sequence position has just been set to 0. So imagine now that is a 0, and that 1, what we are doing is we are telling it to set itself to that value. Then what I do is I'm going to set the LED timer to a value of millis plus sequence array, the LED sequence position 0. So what I'm going to do is say, what is the time now in milliseconds? And I'm going to add to it this value. So what we've done now is we've set the pin for the first position. It's going to set the pin high. We're going to set the LED timer, and then what I'm going to do is increment the LED sequence position. So this means that this now has a value of 1. Now if you can imagine, the code is going to exit here. So let's work through our code process. We start off, our code is going to check if we've done anything with the buttons. If we haven't done anything with the buttons, it's going to come to here and it's going to say, has this condition been met? Now, if we've pressed the button and the first sequence has gone through, it won't immediately jump to the second position, even though we've incremented this value. So this will be valid. But because the timer hasn't yet gone round its, if you like, its 0.2 of a second, 200 milliseconds, this part of the if statement will not be met. So the Arduino will be whizzing round and round in circles, checking the buttons, checking this, checking the buttons, checking this, until that timer is met. But what that means is that at any time, if I press the button, this code here can overwrite what's going on here. So if the sequence has started and I then press the button, it turns the LED off, it sets the sequence position to 100, which means it doesn't matter what the millis timer is doing, because the sequence is now greater than 18, this code will never run. The LED will be turned off. And we can see this in my code. I'll just open the window so we get it properly. So what I'm going to do now, I'm going to press the button. Notice I've pressed the button, I've released the button, I'm going to press the button, I'm going to hold it down. Now I'm seeing my LED start to go through the sequence. If I release it though, the sequence now stops, even though it's halfway through the sequence. Press it again, sequence starts, release, sequence stops, and it doesn't matter at what point in the sequence that code stops. Now I've done this for an LED, and the reason that I created quite a complex sequence was to help you. I've seen some people where they're trying to get musical tones that they're trying to play. Again, all you would do is replace these values with, you'd have your tone in here, tone frequency, and the time that you want the tone to play in there. And where we are using buttons here, we could be using an infrared control. This could be a switch statement, as different controls are coming in off an infrared controller. We could have values that are being read here that are coming off an analog pin. Let's imagine we've got a temperature sensor out there that suddenly we want the LEDs to change. At the moment we've got one statement for one particular LED. This could control a number of LEDs, but the bit that you've got to get through your mind is that you have to allow the code to be going round and round in a loop. As soon as you've put a delay in, your Arduino just stops. And if you've gone down a system where once your sequence has started there is no escape from that sequence, then it doesn't matter how many times you press the button or send your infrared code or whatever, nothing is going to change. So I hope this has been helpful in understanding the basics of how you join two sketches together. What we've achieved here, as you can see, we're now seeing our buttons pressed and released. Again, we're only seeing that written out once. I would advise you, whenever possible, to do serial prints in your code. It's a great way of finding bugs. You know, I can now see the code did actually run at this point. You can always, you know, comment it out later and get rid of it. But being able to see that your code has run at different points is very, very useful. Sometimes I'll just get it to print 1, and then down here I might get it to print 2, 3, 4. So if you like different bits in the code, I just get it to print a different value just so that I know that it's got to a certain point in my code. So I hope that's been useful, and if it has, you know, I hope it will help you to enjoy using your Arduino. They are great fun. They are really great fun. You can do all sorts of projects, and if you can get your head round the basics of joining a sketch, learning to use especially that millis timer, making sure that you're debugging properly with your serial print statements, that you are keeping a track of the pins that you're using. If you can do that, you have the basics to building any project. So I'd advise you to have a mess around with this very, very simple project, and then as you start to get examples of code, start to alter them into this format, and you will be able to join anything together. So have great fun with your Arduinos, and if it's been useful, click the like and subscribe. Bye for now.